Hi everyone. This video is about the second topic from section 5.1 about discrete random variables, and the topic of this is expected value, and primarily expected value in games. Now the first example, this guy right here, we did this if you watched the video for the reading. That's the example that was in the reading. So let's scroll on down here and look at a second example. This example has to do with the game of roulette. Now in roulette, if you're not familiar, it's this big wheel right here. It is spinning around and around and around, and there are 38 possible outcomes where a marble could land on this wheel. So the marble's like moving around. I don't know if you can see that very well, but maybe it lands on the number 29 right there, possibly. If you happen to bet on black 29, you would win. If you happen to bet on odd, since 29 is an odd number, you would also win. So the problem here is somebody walks up and they decide they want to bet on even. They want to bet it's going to land on an even number. Okay, so if you count all the even numbers here, there's actually 18 different even numbers. There's for example, a 12 and an 8 and an 18. If you add them all up, there are 18 of those. So the probability of getting an even number is 18 out of 38. Now, if you win that bet, you win $10. However, if you lose, meaning it's not an even number, also the green 00 right there and the green 0 right there, those do not count as even. So if you lose, the probability is 20 out of 38 opportunities to lose, and you would lose the same $10. So to calculate the probability, we multiply straight across. 10 times 18 over 38 is 180 over 38. And negative 10 times 20 over 38 is minus 200 over 38, which is negative 20 over 38. Now, negative 20 over 38 is approximately negative 53 cents. So this is about, as a decimal, it's negative 0.526, or really negative 0.53, because normally we don't think about money to the third decimal place, just to the second. So you're going to lose about 53 cents every time you make this bet. So if you bet 100 times, you would lose about $53. All right. Now the second example, this is about a raffle, or actually it's the third example, second we're doing in the video. This is about a raffle. In this case, there's a $400 grand prize for the raffle. 400 right here. And so that means that if you're buying a raffle ticket for $10, then you would actually win $390, which is where this $390 right there comes from. Now you could also pay $10 and you could possibly get a $20 gift certificate to Arby's. And so since you paid $10, that's really $10 that you would win. If you consider going to Arby's a win. Now, if you lose, of course, you simply lose your $10, which is why it's negative. And these are the probabilities right here associated with that. Those are the probabilities. Whee! Okay, so the same idea as before. We're going to multiply each x value times its probability and then sum them up. The sum right there, that will be the expected value. So 390 times 0.015 is 5.85. 5.85. And 10 times 0.085 is 0.85. And negative 10 times 0.900 is negative 9. So that all adds up to, better change this to red, this all adds up to a negative 2.30, which tells you that you will lose about, on average, $2.30 for every ticket you buy, for each ticket. All right, fine. So that answers part A, that's the expected value. Now part B asks, if a rich donor bought 1,000 tickets for $10,000, because they are after all rich, how much would she expect to lose? All right, well, to find out, if you bought 1,000 tickets, you would take 1,000 times negative 2.30, and that would be equal to minus $2,300, right? So that makes sense because the rich donor spent $10,000. She's going to win a few, but on average, she's going to lose. She's going to lose $2,300 out of the $10,000. All right. What is the overall chance of winning in this problem? If you will go back up here and you look, winning is the combination of these two categories, 0.015 and 0.085. It's also the complement of losing. And since there's a 0.9 chance of losing, there must be a 0.1 chance of winning. 0.1. That's equal to 0.015 plus 0.085, or you could think of it as 1 minus 0.9. Either way, it's 0.1. Okay, we're going to skip the dice game, and we will go to the life insurance problem. The life insurance problem is probably the trickiest one. If you buy insurance, you're gambling that you're going to need it, and you're spending money in a way. If you don't have to use the insurance, then you've lost that money. So in order to win the money, you need to actually use the insurance. So if it's a life insurance policy, it's really tricky. But we're going to look at this from the perspective of the insurance company. So we're going to suppose that it costs $200 for a $250,000 one-year term life insurance policy for a 20-year-old female college student. Now, according to statistics, the National Vital Statistics Report, the probability that a student survives the year is 0.99952. So if the student lives, the probability is going to be 0.99952. And if the probability that she lives is 0.99952, then the probability that she dies must be the complement. 1 minus 0.99952 is 0.00048. Okay, so those are the two probabilities, living and dying. So if she lives, then the insurance company keeps her $200. So that's the way they look at it. The insurance company will keep $200. They win $200 if she lives. Now, if she dies, they're going to have to pay out $250,000, which is $249,800 is what they would actually have to pay because they took $200 in from her earlier, so that's what they would lose. Now, to find the mean, we just multiply straight across. 200 times 0.99952 is 199.904. And the loss, I should put a negative right there, negative 249,800, that's how much they're going to lose, times 0.00048 would be negative 119.904. And so that leaves you a net balance of $80. So the expected value of the policy to the insurance company, they expect $80. That's how much they expect to make. If they happen to sell 20,000 policies, well, then that would, how much would they expect to make for that? Well, 20,000 times 80, which is equal to $1.6 million. So if they sell 20,000 policies and they're making $80 per policy on average, then they're going to make about $1.6 million. So I guess that's pretty good. Well, I hope that helped, and I hope that you're enjoying this and you're staying safe. All right, bye-bye.